Welcome once again. This is Chibuzor Math Physics, and we are here again with a new concept on how to calculate electric charge. So today we are going to be dealing on capacitor, and we would like to differentiate the meaning of capacitor and the capacitance. So what you can help us, what is the meaning of the capacitor? Is a device that stores electric charge. Excellent. So that is the only way you define it. There are so many definitions about that, but very simple. It is a device that stores electric charge. And what is a capacitance?
Capacitance is the ability of a component of a circuit to collect and store the electric charge.
So can you differentiate for us the difference between a capacitor and a capacitance?
The difference between a capacitor and a capacitance is that a capacitor is a device. A device, while the capacitance is the ability of this device to collect and store electric charge.
So the ability of that device to collect and then store electric charge. And we know that the total capacitance is given by C total is equal to C1, C2 into C1 plus C2. So today we are going to be deriving this equation on how we got to this point. So assuming that you are given an equation to show, the equation is show that for two capacitors in series, the total capacitance is given by C total is equals to C1, C2 by C1 plus C2. So first of all, we need to draw the circuit that we show two capacitors in series in order for us to derive this formula. So let us begin immediately. In our circuit, we have two capacitors in series. This means that the capacitors are in series. Of course, it has a voltage source from this is the negative side and this is the positive side. Now, this is our two capacitors. This is supposed to be C1, isn't it? Yes. This is C1, which means that from this distance, this is our V1. And this is our C2. Is it? So this is our V2. V2. And this place we have what? The source, the voltage source. So this is our voltage source. It means that for us to get the total capacitance, which is given by C total, is equal to C1 multiplied by C2 divided by C1 plus C2. So we need to start by the voltage. It means that our voltage is given by V1 plus V2. Excellent. So at this particular point, what next are we supposed to do? We find the total charge. So now we are going to look for the total charge. And to get our total charge, we are going to use what? So we are using the formula Q is equal to CV. But remember, we are going to make V the subject of the formula in order to find C total. So you will have V, it will be given by Q all over C. So it will be given by V is equals to Q all over C. That means that our Q all over C will be given by
Q
over C1. Q over C1 plus Q over C2. Now, at this point, we can collect the LCM. But before you collect the LCM, you will have Q over C is equal to Q because we have Q. We factorize Q. We have 1 over C1 plus 1 over C2. That means that this Q and this one can go. So we have 1. Yes, this is Q over C. Yes, we are going to look for the C total. So now if we factor out Q, we are going to have 1 over C, which means that now we are going to have 1 all over C total, which will be given by, we have what? 1 over C1 plus 1 over C2. So what are we going to do from here? So we find the LCM. Let us create space here in order to find the LCM so that it can be very visible. Now, to find the LCM of these, we will end up with 1 all over C total, which will be giving us C1 plus C2 into C1, C2. Now, we are going to take the inverse of this so that we have C total. So C total will be then be given by C1, C2 all over C1 plus C2. And this is our formula for calculating the total capacitance. I hope you enjoyed the video on how to calculate the total capacitance in series. There are other ways to calculate the total capacitance in parallel. But first of all, you know that the voltage, we have one voltage source. So you need to add V1 plus V2. And when you add V1 plus V2, you are using our formula in order to get the total capacitance. So in our next video, I will take you through on how to calculate the total capacitance, but now it will be in parallel. See you and enjoy your day.